Hello and good evening. It's so nice to be here in this place at this time, working on myself. Today, we're going to find some antiderivatives and a little bit of tomorrow. Looks like we are good. Okay, I'm going to get going. Oh, wow. Oh, Jesus fucking Christ. No. Ugh. God. Okay. I see that you're here. Nice to see you, Angie. I'm sorry, I have to go two-factor authenticate myself to get into my chat. Okay, okay. Welcome, welcome. Sorry, I forget. I'm on my other microphone, so you can probably hear like every little noise I'm making. Okay. Okay. Wow. Okay. Okay. Then let me. Hmm. Okay. Oh, I know. Uh, integration. Okay, yeah. I'm gonna be best off just doing these ones. Okay. Um, hope you're still there. If not, that's cool. Let's see. Gosh, it's so hard to keep all my panels straight. Okay. Where's chat? There it is. Okay. So for our first problem, Oh, hi. Hi, hi, hi. Okay, sorry. My control panel tells me I have zero concurrent viewers, and I don't quite know what that means. But I'm glad you're still here. Okay, so judging judging by I don't know how far you've got into math, calculus is oh my gosh. I'm always sitting on a pivotal chord and destroying everything. Okay. So, calculus basically is derivatives and anti-derivatives. Um, so this symbol right here is the antiderivative. The actual symbol looks a little different, but that's like the easy shorthand way to do it. But that's basically it. And then our problem is going to be x times the square root of 1 plus x squared dx. Um, I don't know. I guess I can start with like a way simpler example of just like generally what an antiderivative is. Um, Maybe very simply, I'll show you it back and forth, like a derivative the first way. Like, say you have, um, oh my gosh, no. So, say that's your function, and they want you to find the derivative, which is denoted like that. Well, it's not, it's not like it's not super hard. It's just, there's just a lot of steps. It's like I don't know, but derivatives is like the base end of it. So like, it's actually a really simple process if I should just show like a really quick illustration of it. So to find the derivative of this problem, you bring this 4 right here, and then you times it by 3, and so that becomes 12x, and then this 4 becomes a 3. And that's it. That's the or I mean, that's the derivative. So the antiderivative is just exactly the opposite. So if you had a problem that said, um, um, this would be equal to this original function right here, right? The first thing we started with, because it's exactly just the opposite process. So instead of taking a number away from the exponent, you add a number to the exponent. And instead of bringing it forward and timesing by it, you would divide by the new number, which would be 4. So 12 divided by 4 would become 3. So that's like a really simple example. It's pretty cool, but calculus 2, which this isn't calculus 2, this is just we're reviewing calculus because we're about to get into finding the area between curves, which is pretty rough. But anyways, so we're reviewing stuff right now. So this is a antiderivative problem. And so they tell us that the approach to it is a U substitution. And what this means is just essentially that you are going to create a new variable, and it's going to be equal to something from within this expression. Um, but the catch is, or the point of it is you want this as derivative to be in this problem. So for you, I'm gonna pick this expression right here. Okay, so now I want to find the derivative of this expression. So the derivative of any constant number is just 0. So we don't have to worry about that. So now we're only left worrying about x squared. So since it's a derivative, not an antiderivative, we're gonna, oh my gosh, we're gonna take one away from that, and then we're gonna times the front expression by 2. Well, okay, I mean, not that. Sorry, that's already gone. We're gonna we're gonna times x by 2. So it's just gonna become 2x. Sorry, that I did that really confusingly. Let me see here if I can go back. Okay, so we're already, the derivative of this is 0, so we're not even worried about that. So now we just have x squared. So it just becomes 2x. So now, in the grand scheme of trying to find this antiderivative, we want to get this 2 on this side. So we divide it over here. And then I almost forgot a really important part. The derivative also contains a dx variable. So this is what we're left with after we find the derivative and then solve for x dx, I suppose, is 1/2 du. And the reason this is also important is because this expression right here is this, exactly this, because, well, okay, except for this. So this is just a constant number that's going to come out front of our integral. So let's rewrite it. We've got 1/2 times the integral of, okay, so now we have 1 plus the square root of x. So what we're going to do for this is we're going to change that from a square root into a power, and it's going to be the 1/2 power. So okay, so u is 1 plus x squared, and so we have u to the 1/2 power, and then we have this x and this dx right here. And that x dx is literally this. Okay, so sorry. So I guess I should have made this purple. So now hi, Jonathan. What is seen? Do you mean sign? I'm so sorry. I'm so sorry. I didn't mean to just do that. No, thank you so much for being here, for subscribing to this channel, first of all. It's so cool to have a subscriber. Thank you, you're so sweet. And thank you so much for watching my music streams. And I hope, oops, resizing the wrong thing. Okay. Now I want to try to do whatever problem Jonathan just suggested. Oh my gosh. I'm gonna take that as the integral of sine cubed of x over 2 times cosine to the 7th of x over 2 dx. Okay. Well, fuck me. Well, let me see. Sorry. Sorry for my foul mouth. Well, I mean, clearly, if we do, okay, I think we're gonna have to do it by parts here. So if we do u is equal to cosine x, then du is equal to sine of x dx. So dv is going to have the dx in it. So it's be shoot. Oh, cool. Yes, I have a bad mouth. I have a bad mouth. I don't know if I can do this. I'm I'm so rusty. Let me see. Let me go to my pamphlet. Oh no, I have to go to Okay. I don't know if I can do this. I'm so sorry. What about you, Jonathan? Are you good at this stuff? Do you know for a fact this problem is solvable? Oh, really? Um, comes out by trigonometry. Okay. Well, I can't do it right now. I can let me do it and put it on my stream tomorrow. I am gonna work on the kind of stuff I was doing for my notes today in class. So I think this is gonna require integration by parts, but I'm not 100% sure. That's why I'm retaking calculus 2. Why the heck can I see the damn chat? Okay. All right, so we have the integral is equal to x squared times e to the x cubed dx. So first we want to find our u. So this is kind of tricky, to be honest. I guess it's probably because of how this all behaves. But so you would think it was going to be like x squared probably, or possibly e to the x cubed, but it's actually just x cubed. And so then when you go ahead and find its derivative, which again, you're just going to bring the 3 down and then make that a 2. So 3x squared, and okay. But then you have to, so out of this, oh, oh, I almost forgot the most important part, the dx. So now you look here and you see, ooh, this is right over here. So you're going to divide this to the other side. So it's times by x squared, so you're going to divide, and it's going to become 1/3 of du is equal to x squared dx. So now putting this back into terms of this problem, so u is x third, so we're going to have e to the u, and then x squared dx is going to become 1/3 to u. Oh shit. Oops. Okay. Thank you again so much for being here for my first stream on this channel. It's all new territory for me to be having my, like, I have so many different Apple devices hooked up to this computer right now. But I got my iPad going, I got my iPhone streaming my video. Anyways, it's a new venture and it's cool and it's hopefully gonna help me do better in my class. It's like my ultimate goal, but also if somebody can like get help through this or can help me, all the better. Mm. All right, back to our problem. Back to the lecture at hand. Yeah, I was so late because I was well run one I had to run to the store, but then I was trying to get music set up in a fashion that yeah, I hope so. Um but I was trying to get music set up on my stream in a fashion that wasn't gonna like kill my computer CPU, and I'll try again tomorrow. But so yeah, sorry I was so late. Thanks for sticking up and around. You must not be in Australia. Okay, back to our problem. Okay, so we got 1/3 times e to the u. Okay, sorry. Oh, nice. Okie dokie, let me see. I'm just scared to get to one that I can't actually do. Um, so here, I think this is the problem. Oops. Okay. 5 to the t times sine of 5 to the t dt. Oh dear. Let me see if I can first get u. Let's see here. If we make u sine, then its derivative would be cosine of 5t times whatever the derivative of 5 to the t is. I think it is 5 to the t over lane of 5. So that would be the derivative, which I don't think we want because we want it to be this, essentially. Oh, wow, my computer's dying. Let me see how much battery I have. Ooh, 28%. Okay, I guess I gotta go after this one. Plus, I guess I gotta go to bed anyways. But let us see if I can figure this out. So, essentially, we don't want to do any of this. Let's just go ahead and make it 5 to the t. I don't know. Guess so. Yeah, that's the answer. Let's see here. Okay, so 5 to the t. So then, as I said, our derivative of 5 to the t, this is just like a formula that you have to know. Um, a to the u, a being a constant, u being some expression, is equal to a to the u over ln to the a. So we have got 5 to the t over ln of 5. Oh, dt. So the way I would think that we can get what we want here is to just times this ln of 5 over here. So we have ln of 5 du is equal to 5t, or 5 to the t dt. And I don't know if this is right, to be perfectly honest. Um, that is not right. Thank God I have the answers. Okay, so we have the derivative. And then we're going to solve for dt. So I would think it's just going to be the reciprocal of this, like ln of 5 over 5 to the t du. But I would be wrong. I don't understand. Hmm. So it is 5 to the t times ln of 5. Hmm. I'm so sorry. I don't understand. Oh, you're so good. No worries. I wish I was better. It's kind of embarrassing, but it's you have to fall to get right, I guess, or to do good. You have to do bad to do good. Um, all right, I'm trying to figure out how I'm getting to this answer. It's becoming du. Okay, well, I guess that I did. Oh, you know what? I'm so wrong. I'm thinking of it backwards. This is what I'm like I said, the derivative and the antiderivative is just like the opposite of each other. So the antiderivative is division, but the regular derivative is times. So it's 5 to the t times ln of 5. And so then, okay, now we're good. Divide by that, and we end up with du over 5 to the t ln of 5 equals dt. And the reason we did this is because we want that. And so, let's see. Okay. Okay, so I thought we were going to switch to you um, already, but I guess it would make sense that we do not yet. So we are going to rewrite it. And then dt is going to become du over 5 to the t ln of 5. And this is going to allow us to cancel those because this is 5 in the numerator and this is 5 in the denominator. So those will cancel, leaving us with the antiderivative of sine of 5 to the t times du over ln of 5. So the ln of 5 looks like it would be like a variable like that or something, but it's not. It's just a constant number. It's the same thing as saying like a 4 or a 7. Like it's just a number. So we are able to take constant numbers outside of the integral. And since our ln of 5 is in our denominator, it's going to be 1 over ln of 5 that we're able to bring out front. So we rewrite this as 1 over the ln of 5. And now we can finally switch to u. Sine of u. And now we want to find the antiderivative for sine of u. So if we were finding the derivative, it would become cosine of u times the derivative of u. But again, since we're going in reverse to find the antiderivative, we want negative cosine of u times the derivative of u. Okay. Different color. We'll do a different color. We don't write the du anymore because we have done the interval. So now we can also go ahead and write our plus c, and this just stands for a constant number that we don't know, because when you take the derivative of a constant number, it just becomes 0. So this is where calculus, and specifically calculus 2, as I remember it, gets really annoying because it's just like you're not done yet. You just there's still more steps. No, there's only one more step, but like oh my God, some of these problems there's like 30 steps, and my whole last semester of this was on was on Canvas, was through, I forget the name of the company, but like all of my math assignments were on the computer, and it was a hassle. Anyways, finally, our answer to this problem is negative 1 over ln 5 times cosine of 5 to the t plus c. It is a lot of practice and oh no, let me see here. Oh sheet. Oh sheet. Sorry. I have to go. My computer is at 10% battery. I had to unplug the power charger to my computer because of all the other shit that I have plugged into my computer. So I gotta go before my computer dies. But thank you so much for subscribing and for hanging out and watching the music. I don't know. I don't want to say thanks too much, but thank you so much. I appreciate it so much. And I will be back tomorrow night. Probably the same situation. I'll probably be playing music. Well, I'll definitely be playing music at 10 p.m. and then I'll probably work on math after that. So cool. Well, you have a good night, Angie, and I'll see you soon.